Last big talk of the day before we go to open spaces and other fun stuff. We have Seth Eliot here. He is a repeat speaker. We had him here before, and we loved him so much we wanted him back. I actually saw Seth first time at reInvent. I think it was 21 or 22. I can't remember. But right now he's a principal resiliency architect at RPO. He has a ton of experience in real life with large-scale systems, resiliency, recovery, and all the things. And I love how he brings to his talks a lot of the real-life learnings over time with some of the biggest companies. One of them might run a cloud. The other one might sell me way too many packages that show up at my house. So he's going to talk about DevOps strategies for cloud disaster recovery. So welcome, Seth.
Thank you, everyone. Hello. Yep, hi there. Talk to you about, we're going to talk about disaster recovery today and sort of a DevOps take on it. And first of all, who am I? Well, Mark did a great introduction. I'm telling you who I am, but a little more detail. I actually wrote the disaster recovery white paper. That's AWS's best practices for customers on how to do disaster recovery. That's the thing you see there. Created several other artifacts for AWS that are still out there and still being used. That's what I did do for 5 years at AWS. And now I'm with a company called RPO. And RPO is providing easy disaster recovery for AWS workloads. So that's why I want to talk to you about disaster recovery in the cloud. I'm going to use AWS as my example, obviously. But really what I'm saying here applies to any of the cloud providers. And so you could judge a talk by the number of exclamation points in the title of the slide. So that's why I put 3 here. So the fiber-seeking backhoe, who's heard of this beast? Yeah. So it subsists on a diet of fiber optic cables, and when it can't find those, maybe power cables. And this is a disaster that can strike your on-prem data center, but it can't, and the cloud actually insulates you against it a little bit by providing more redundancy, but believe me, it can help take out a cloud deployment also. So disasters happen, and we have to be prepared for them. And towards that end, my company, whenever we have a booth at like reInvent or a summit, and we're going to be at reInvent, so come by and say hi, and you could spin the wheel of misfortune. The wheel of misfortune consists of a bunch of actual disasters that have occurred in the real world that have taken down cloud providers and the people using them. And you see this at the bottom there, there's one quiet day wedge. And if you get the quiet day wedge, you'll get a gift certificate. So come by and spin the wheel. But let's play a little game here today, all right? So cloud provider cleanup automation accidentally deletes your environment, 7-day outage, May 2024. Anybody know which cloud provider this was? Yeah, I heard, yep, this is Google. So Google wiped out one of their customers' environments, a customer called Unisuper, and they were down for 7 days solid. All right, next one. Businesses refuse connectivity after your hack, 90-day outage. Now this one's a little bit of an unfair one because the refusing the connectivity part is not really what made the news. What made the news was that they were hacked, they were ransomware, they had a data leak, and they were down for over 90 days. But maybe from the timestamp you know who this is. Just shout it. Yep? No? Anybody know who this is? Last year, major hack, major ransomware hack, Change Healthcare. You heard of that one? Part of United Healthcare. So the interesting thing about this is they provide the integration between doctors' offices and insurance offices. They're sort of a system integrator, right? And what didn't really make the news was even when they came back up, okay, even when they brought their systems back up, the doctors' offices and the hospitals and insurance companies didn't want to connect to them. They'd just been hacked, right? So you need a recovery strategy that not only brings you back up, but that shows your customers that you're safe. All right, last one. Cloud provider adds capacity. Servers exceed max threads allowed. Cloud services go down, 17-hour outage, November 2020. Anybody know that one? I mean, it's very related to the one Kyle just said, which was the December outage. This was the year before that. This is the Amazon Kinesis outage that not only brought down Kinesis, but a bunch of other services that use Kinesis in US East 1. So disasters happen, all right? Now, I'm not here to scare you. I'm not here to like have you react in an irrational way because bad things happen. I'm actually here to help you feel better. I'm here to give you the tools you need to actually make your cloud workloads survive these and stay available and serve your customers and serve your business needs despite this stuff happening. That's what I'm here to talk about. And towards that end, I want to talk about disaster recovery. Disaster recovery is what's going to keep you running in the case of these large scope events. So disaster recovery is about protecting you against the large scope events that are rare, but have such a scope that they often require for you to actually recover at an alternate site. You can't recover in place. It's not like high availability where you just like replace a server or go to a different availability zone. Disaster recovery means you're going to come up in a different site. So towards that end, let's talk about some of the requirements. And this is a bit of an eye chart, but if you look on the left, that's your source workload. And I just put together a workload. It's got all kinds of goodies in it. It's got Lambda, it's got Kubernetes, it's got EC2, it's got DynamoDB, it's got an RDS database, it's got all kinds of stuff in it, right? That's on the left. Now what you're seeing there in the middle is what we need to do. That's what we need to create inside the we need to create this. This is all the backups of not just the data, but backing up the infrastructure. We're using secrets manager. We need to back up those secrets. We're using Kubernetes. We need to back up those Kubernetes manifests. We need to back up everything in there. And as I said, it has to be a different site. So it's going to be a different AWS account and a different region, cross-account, cross-region, so that if a disaster occurs, we can rebuild the whole thing. Again, we're going to rebuild it in an alternate site. We're going to rebuild it in a different account and a different region, so it just all comes back up. That's what disaster recovery is, and we're going to talk about building that today. So our first requirement is what I've already been going on and on about, the recovery site. Where do we need to recover? So these are the three kinds of categories of disasters that I always talk about when I was with AWS, and they're all valid categories: natural disasters, technical failures, which include bad cloud pushes, and human actions, which can be benign, but most often are bad actors, malware, ransomware, that kind of thing, right? And what I did over years of talking to hundreds of customers when I was in AWS, I realized that these categories are just fine and dandy, but really there are two subcategories that happen with any regularity. The first subcategory is the one I kind of already mentioned earlier with a Kinesis outage, which is called an AWS regional event, meaning people talk about regions going down. Regions generally don't go down. What happens is a service or two goes down, a major networking failure happens. And it doesn't matter whether it's up or down. What it matters is, can you run your workload there? Okay, so when a regional event happens, you can't run your workload there, you need to go cross-region. The other subcategory is the one I've been talking about, is ransomware and malware. Cross-region is not going to help you here. The bad actors have gotten into your account. You need to go cross-account. You need to bring your workload back up in a different region and a different account with different credentials. So that's one of our requirements, is cross-region, cross-account. Another requirement is complete workload recovery. So this is another sample workload. I like putting together sample workloads. I like making pretty diagrams of architectures. And this one has EC2, it has EFS, it has Elasticache, it has Aurora, right? And it's running in a given region, in a given account. And something happens. I just went through the some things that could happen. That means I can't run it in that account or that region anymore. So I'm going to go cross-region, cross-account. And what's the first thing I'm going to do? First thing I'm going to do is bring back my data. Data backup and recovery is sort of bread and butter. That's the ante for disaster recovery. But it's not disaster recovery. Look at the customers. They still have question marks above their head. Why do they have question marks? Because data, while it's super important and is the lifeblood of your company, is not an operating workload. Just the data is not enough for your customers. They need an operating workload. So you're going to need to also bring up the networking, the infrastructure, the security principles used for the services to talk to each other. And finally, configuration translation, meaning when things come up, they'll have different names. Things will need to know, how do I talk to each other? So you're going to have to do that. So you're going to do, that's the requirement, is complete recovery. The next requirement I'm going to go for is less expensive. And this one's a judgment call, all right? So this is not an absolute, but this is the one where I'm targeting my solution that I'm talking to you about today. So I'm not going to talk through each of these 4 disaster recovery strategies, except to say the ones on the left are like less expensive, but also less sophisticated. They have more downtime, more data loss. The ones on the right are more expensive, more sophisticated, more complicated, with less downtime and data loss. I'm going to shoot for the pilot light strategy. The pilot light strategy means that we're going to do all our backups. We're going to We're going to be able to stand everything up when we need it, but not everything's running. It's not a warm standby. It's not a hot standby. And that's going to save a lot of money because warm standby and hot standby implies running servers, running databases, all the things that cost you money. And I want it to work across different workloads. My company has multiple business critical workloads. I don't want to write a disaster recovery solution that's bespoke or custom for a given workload. I want to write a platform. I want to write something a disaster recovery solution that will work across all my workloads. And this is a very DevOps thing, right? We don't want to reinvent the wheel. We don't want to make unnecessary work. We want to do one thing that everybody can onboard onto. Another requirement for my backups, for my data, is that they be incremental and encrypted, okay? So incremental means faster backups. If you're not doing a complete backup every time, you can do it faster. Faster backup means lower RPO. RPO is recovery point objective. It's a measure of data loss. High RPO means more data loss. Low RPO means less data loss. And so you want lower RPO, so you want incremental backups. And by the way, the name of my company, if you didn't get it already, RPO, you get it now? Make sense? Just nod your head, all right. And we want secure, and we want the encryption because we want our data to be secure both in transit and at rest. So in this diagram here, you see again this cross-account, cross-region that I've been talking about. Now it turns out for many different data types, especially in the AWS ecosystem, you actually can't go straight cross-region, cross-account. You actually have to go through an intermediate step. So we need this incremental backup and encryption to actually work across these multiple steps. And reuse, right? We always want to reuse the tools that we have if they're good tools. We don't want to reinvent the wheel. Along the bottom here, you see a bunch of data backup and data replication technologies that AWS offers. You see AWS Backup, which is a great tool. AWS Elastic Disaster Recovery, another great tool for replicating EC2 instances. And then along the top, infrastructure as code, the SDK. This is what's going to help you to actually replicate and stand up new infrastructure and networking. So we want to make use of these tools wherever possible. And we need it to be testable, right? So a big thing in DevOps is measurability. How do we measure that we actually have disaster recovery, right? So we're going to measure it by testing it. And when we do a test, we need it to be a test of a complete functional workload. A test can't be part way. Test means we bring up a full copy of the workload in our recovery site. Other aspects of the test that are going to be important to us are it continues taking backups. If this were a real failover, then now we're operating out of the recovery side and we don't care about the primary side. But this is a test. We still need to take backups of the primary side, otherwise we're not going to meet our RPO objectives. We want a network sandbox or bubble testing. Put a firewall around it, because what did I just say? This is a complete functional workload. It's going to come up in the recovery environment. It's possible, depending on your architecture, it could interfere with production. So we're going to put this bubble around it so it doesn't interfere with production. And we want tear down just as easy, right? We want to be able to test it, bring it up, and then tear it back down so we're not paying for resources we're not using. Next requirement is multiple recovery points. So we want to actually be able to, at a given point in time, back up everything. Again, this is not just data, but data, infrastructure, networking, everything. We want to back up everything, and we want to be able to save those backups. So you can see there's a retention policy of how many backups to keep, how many to keep for the past weeks, years, months, so you can actually meet your compliance needs. And also the thing about having multiple recovery points, this is really going to help with the ransomware case. Imagine you're attacked by ransomware today. You can then do a point-in-time recovery of yesterday, bring back good data before the ransomware ever attacked it. You're bringing it up in a separate account, separate region, and you're back up and running. All right, so this is the last requirement I'm going to talk about before we move to actually design this thing. And I'm going to actually take several slides to describe it. And the first slide is to tell you about the shared responsibility model for resilience. Now, the shared responsibility model for resilience is something I helped come up with. I co-authored it. And it says that AWS has responsibility for resilience, and you have responsibility for resilience, both. It's a shared responsibility. The AWS responsibility is to provide you a lot of those cool tools I was talking about, to provide you with resilient services, to provide you with fault isolation boundaries like regions and availability zones. Like if a fault happens in a region, it's very unlikely it's going to affect another region. That's why going cross-region is so effective. And that's AWS's responsibility to do that. Your responsibility, the customer, you could see things like workload architecture and testing. Your responsibility as a customer is to use the tools. and put them together in such a way that you're following the best practices of the well-architected framework. So that's your responsibility. And when you look at this model, there's a clear line between what AWS responsibility is and your responsibility is. And this diagram would seem to imply that line's kind of static. It's always in the same place. But that's actually not true. The line can move. When the line moves down, that means AWS is taking less responsibility and you're taking on more responsibility, which doesn't sound like a good thing, right? So we want to avoid that. But let's see what that looks like. Let's move the line down. In this case, we're making use of the very powerful primitives that AWS provides. AWS provides the ability to back up every data store, to replicate your S3 buckets, to do all kinds of things on a resource-by-resource basis to back up your data. But that means to create an effective disaster recovery solution, you have to do all the stuff on the top. And I'm not going to read you every bullet, but for instance, you're going to have to set up the backups across every resource type. You're going to have to set up the restore across every resource type. You're going to have to copy those backups cross-region, cross-account. Networking and infrastructure, not even covered on the bottom here. You're going to have to restore that yourself. So there's a lot of responsibility. So I call it the customer responsibility heavy model. So let's see if we can move the bar up, because we want to move that bar up, right? The whole point is we want a customer to have less responsibility here and offload that responsibility. So we move that bar up, and now we're making use of services like AWS Backup or Elastic Disaster Recovery. And now AWS Backup's a really cool tool. It's a single pane of glass across all those backups I was talking about. So no longer do you have the responsibility for coordinating those backups. Just set up a backup vault across multiple resource types, and you're good to go. It also takes care of copying backups cross-region, cross-account. So I took that off the list too. So you have a lot less to worry about. I included a Resilience Hub here also. Very cool product. I worked with the team to help basically design and build it. But and they provide some functionality here around resilience too. But let's move that bar as high as we can. Okay, this is what we're going for. This is what I want to design here when we're talking today. I want to do the automation and orchestration of all these things on the bottom, and I only include a few things, a few icons there, but there really should be dozens of icons there across backup and Bodo 3 and using step functions and everything else. And I want this all orchestrated for me to back up and restore my data, back up and restore my infrastructure and networking, and do any configuration translations I need. I want that all orchestrated for me. Now, it just so happens that the company I work for RPO, does this. This is what they do. So on the next slides, I want to talk about design considerations. We're going to try to actually now design this solution with the requirements that we were given. And it makes sense. I'm going to share with you some of the decisions that RPO took when building this, because RPO was trying to meet these requirements and does. And the decisions that we made, I think, are illustrative. So I want to share those with you. So let's get into building the actual disaster recovery here. Okay, first of all, we need to get that data cross-region, cross-account. I keep saying that because it's so important, right? So you have a database sitting up here in your source workload. It's sitting in your source account, source region, and it's easy enough to make a backup in the same place, right? So the backup's in the same region, same account, and that backup is being encrypted using an AWS managed KMS key. So now, as I told you before, we can't copy it directly cross-region, cross-account. We're going to take this intermediate step. We're going to copy it down here. We're going to copy it into the cross-region same account. But not only that, this is where it gets clever, okay? We also created a key in the recovery environment. This key is a customer-managed key. It's not an AWS-managed key anymore. It's a customer-managed key that lives in the recovery environment, and we're encrypting our backup with that key. And that makes it so easy then just to share this across and now copy it where it needs to be, right? So we can now use these commands. You see the commands in the upper right-hand corner of the screen? AWS gives you powerful tools. It gives you the ability to copy snapshots, it gives you the ability to encrypt them, it gives you the ability to share them. So I'm just making use of these tools that AWS has given us to now copy this. Now we have an encrypted database in the recovery environment, encrypted with a key from the recovery environment. And as long as we maintain at least one copy in that intermediate environment, you see where it says greater than or equal to 1 ensures incremental. As long as we have at least one copy there, it'll be incremental. So it meets our encryption requirement and our incremental requirement. Now, when you actually need to recover, you're going to restore that database, and now you're back up and running. Oh, the one thing I forgot to mention here is that AWS does provide the ability to copy directly cross-region and cross-account for some resources, but many resources like RDS, it doesn't. And for many resources like EBS, the block store, if it's encrypted, it doesn't. So that's why we're using that intermediate step. All right, so this is a similar requirement, a similar design consideration, only these are things that don't, remember how the other one I had these nice commands for doing copying? These don't have any copy command in AWS. Things like secrets, which are your database passwords, parameters, or EKS manifests, especially EKS secrets. There is no native AWS way to actually copy these across regions, cross account. So what we did at RPO is we deployed Lambdas in the source and recovery environment. So let me focus your attention down here. All the other stuff up top is about authentication. But focusing down here, we have a Lambda on both sides. And that Lambda can literally read the secret and do the trick we did before, which is get a key from the recovery environment, encrypt the key with that, encrypt the secret with that key, so that secret's safe in transit, and then send it over on its way to the recovery side. And now let's talk about cross-region, cross-account of real-time replication, right? We actually might have a need for that, right? Instead of just doing backups across region, across account, we want to do real-time replication across there. And this is the other thing this is meeting, which is not mentioned on the slide, is we want incremental backups of DynamoDB. So DynamoDB has the ability to do a backup, a manual backup of it, but every manual backup is a complete backup. This enables us to do incremental backup. And you can see on the left, all we have to do is enable streams on our DynamoDB database. We deploy a Lambda. That Lambda gets triggered by the streams. That Lambda is given permission to write to an intermediate, against that, again, that intermediate concept, intermediate database table in the recovery side. And we then take backups from that table. So now we've got cross-region, cross-account, real-time replication with incremental backups. And so when we need it, we can then either recover from the live database if we need real-time recovery, or we could recover from one of those backups if we're recovering a recovery point. Okay, now that's enough about copying things cross-account, cross-region. I had like 3 slides on that. Let's talk about another issue you're going to face when building this disaster recovery platform. Endpoints are going to change. Right, so on the left, there's AWS backup and infrastructure as code. That means you're going to be standing up stateless things like load balancers or API gateways or VPC endpoints. Or AWS backup might be actually recovering things from backups like RDS instances or Elasticache or things you've backed up. And in all of these cases, they're going to come up with a new endpoint, meaning they have a DNS endpoint that your application talks to them over. So you can see in the source here, hopefully you could read the text. It says, the application's talking to endpoint AAA, and the database is at endpoint AAA, and everything's happy. But when you restore that database in the recovery environment, and your application doesn't know that endpoint's changed, the endpoint's now ZZZ, it's going to fail. The RPO solution that we took was to create consistent, to actually create something called private hosted zones. A private hosted zone is DNS. It's a Route 53 private hosted zone. It's DNS that operates within a VPC. So it's not public DNS. It's totally private, totally within the VPC. And we can actually do all the DNS stuff you'd expect, like CNAME records, to actually remap AAA to ZZZ. And now the application thinks it's talking to AAA. It gets remapped. It doesn't even know. And it's able to connect to the database at ZZZ, all using these private hosted zone DNS entries. Now, your alternative here is to really update the application. Tell the application, hey, the new endpoint is ZZZ. So you'd want to automate that, right? You don't want to do that by hand. You don't want to do that through the console. So you want to automate that when it stands up a new database, some script out there runs and tells the database, tells your application what the new endpoints are. And database, as long as we're talking about databases, let's talk about passwords, right? So you should be rotating your password, right? So this shows a password in AWS Secrets Manager. And the password changes over time, and that's what these little clocks represent, right? Now, let's say you're recovering a database from in the past, not the most recent version, but a prior version. Well, what might happen is you recover the database from the blue clock, but the secret you're storing is the latest one, and it's not the right password, so it's not going to work. So how do we solve for this? Well, we've taken the approach that we create consistent recovery points. In other words, at a given time, and we're doing a backup, we're backing up the database, and now we can back up the secrets because of the previous slide. Remember I showed you how we could back up Secrets Manager secrets? We back up the secrets, we back up the database, we back up the EC2, the S3, the Kubernetes cluster, everything from a single point in time. That way, when we restore it, we know that secret, that password, matches the database. Okay, I'm pressing the wrong button. Human issue. Now, you might be thinking to yourself, the more common solution for folks is simply when they recover the database to change the master password. You could do that in AWS. In which case, if you do that, you're going to then have to update Secrets Manager with the new password or wherever the application is getting the password from. You've got to make sure that's updated. And let's talk about resource identifiers in general. So I kind of alluded to this earlier. When you bring up a bunch of stuff on the recovery side, it's all going to have different names. There's an IAM role, a security role. It has a different ARN. There's a load balancer. It has a different endpoint. There's a S3 bucket and a hosted zone ID. They have different names. So there's ARNs, there's endpoints, there's names. They're all going to be different in the recovery environment. How does everything know to talk to each other? This is where translation comes in. So step number one is put as many of these things as you can into parameter store. You put into parameter store, you got a central location where they are, and you just go through all of them and translate them. And if you see, this is some EC2 user data. User data is what the EC2 runs when it first starts up. You see, in order to get the S3 bucket, it's calling parameter store. To get the private hosted zone, it's calling parameter store. So as long as you translate the values in parameter store, you're good. But we wanted to take this a step further and make this as bulletproof as possible. So you see the bottom one where we're calling the EFS DNS name. We actually didn't put that in parameter store in this case. But we still designed our platform to translate it. It looks in EC2 data, looks in ECS task data, looks in EKS manifests, looks wherever you'd expect to find these kinds of references and translates them when we bring things up in recovery. So that's obviously not all the things you could design, but I only have 30 minutes. I have no idea how much time I have left. This timer is not running. Hopefully enough time. But I just actually am going to wrap it up now by talking about how this all fits into the DevOps principles and DevOps strategies. First of all, culture. I mean, I can't make this point strenuously enough. DevOps is not about tools. Even though I'm talking about tools, I'm talking about design, it's about culture, right? And I believe that creating a platform like this empowers teams, right? Empowers them to own their own disaster recovery. If teams own services, they should own disaster recovery for those services. So they own the onboarding onto the platform. They could do their own testing as often as they want. And even when a failure occurs, when a disaster occurs, they could own the recovery. Although I have a little caveat there, right? Before you push the big red button and recover, you might want to talk to your management, talk to the other teams, make sure that, yeah, this is the time to do a true failover. But you still own it. And automation, obviously, that's pretty much all I've been talking about is automation. Really, you create a platform like this, you're taking all the data backup and restoration pieces and automating them. You're taking the infrastructure and networking restoration pieces and you're automating them. And we talked a little bit about ransomware, but in addition to recovery point, we could also run guard duty against servers after a ransomware attack. We could set up a firewall to prevent any infected servers from doing damage. So we could coordinate and orchestrate that too. And lean. So I believe that this goes back to my point earlier, which I don't like custom-made solutions. By creating a platform that multiple teams could onboard onto, you're reducing undifferentiated heavy lifting, you're reducing unnecessary work, and then every team can onboard into these common tools. And then measurement is all about testing. Like I said before, we want you to launch this test monthly or quarterly. You could actually measure how long it takes to recover. No more estimates of your recovery time. You now know your real recovery time. I can measure that over time. And then run a suite of validation checks, basically tests, against the recovered workload to make sure it's actually recovered and it's working, and then record those too. And finally, sharing. I really think that a lot of times I talk to companies and teams about disaster recovery, they have these organizational friction to adopting it. I think by having a common platform reduces that friction, and teams that have different skill levels or even different knowledge of what kind of disaster recovery they need or if they even need it can all learn from disaster recovery champions, right? Once you build a platform like this, it almost evolves from it that you have champions that know how to use the platform and know what it's used for and can share across the company. So ultimately, you could build this, like I just tried to show you how you could build this yourself. My company has built this. I mean, this is not a sales pitch. I just want to say, AWS gives you the tools to build your disaster recovery. You need to make that build or buy decision based on do you have the time to build it, the expertise to build it. Maybe you want to pay ProServe to build it. That's fine too, right? But disaster recovery is necessary, and it's mostly undifferentiated heavy lifting. Undifferentiated heavy lifting means the things that you have to do that take a lot of time but don't differentiate you from your competitors. Now I say mostly because I think being able to recover and not being able to recover is a differentiator, but it is somewhat undifferentiated. And for anybody out there, you don't have to raise your hand, you don't have to be embarrassed, it owns a workload that doesn't have infrastructure as code. It's ClickOps. Maybe you inherited it, maybe you didn't create it. Get that thing on infrastructure as code eventually, right? You need to do that. But until then, a solution like this will work. So building it yourself without infrastructure as code in place is going to be a lot harder. So maybe using a solution like this that uses the Boto 3 SDK might be a solution for you. Ultimately, make your own choice. I'm not here to pitch you, but I think this is a pretty cool solution and can work for many good customers. And with that, I give you a scan code if you want to set up an appointment with me to talk about disaster recovery. You do not have to talk about RPO. Again, I'm not pitching RPO. I'm just here to talk about disaster recovery. Even if you have some, I might actually do also an open space session on it, but if you want to talk to me one-on-one about the disaster recovery challenges you're facing, please feel free to reach out to me. And how much time do I have left? Do I have any time left for questions? I'm going to take questions so they kick me off the stage. All right, anybody have any questions? All right, over there, and you're going to have to speak up. I'll repeat it, but you have to speak up. Yeah, the question is, how does disaster recovery change if you're talking about cyber recovery, ransomware attacks? And I only touched on that a little bit, right? I always used to teach disaster recovery is the layer below ransomware recovery, right? It's a necessary layer, and high availability is the layer below that. So I think, yes, disaster recovery in itself is not ransomware recovery, but if you add in the tools I was talking about, like point-in-time recovery, like network firewall, guard duty scans, it can be accurate and effective ransomware recovery, yes. I guess one more question. I'm getting like the cane. Yes? Why do we need cross-account? For the ransomware recovery. Ransomware implies your account is compromised. Your source account is compromised. The bad actors have your credentials. They can do what they want. If you go cross-region, they could take that down. They could mess with it. They could stop it from happening. Going cross-account is the only way to be safe. And not only cross-account, but cross-account with different credentials, right? Sometimes multiple credentials get you to multiple accounts. No, you have to go cross-account, different credentials, be safe from ransomware. And I think that's all the time I have. That's all the time I have. Thank you.